everyone, welcome to our YouTube channel Tenacity Online. So in the previous class we have discussed about distance and displacement. In this class we will be studying about speed and velocity, and we will be studying these two terms by the differences and similarities. So let's see the definition of speed. So the speed is defined as the rate at which distance is covered per unit time, whereas velocity is defined as the rate of change of position. This is the rate of displacement with time. So in speed I have not mentioned the rate of change of position, and in velocity I have mentioned this because I have mentioned it in velocity as the rate of displacement covered. That is, displacement is a vector quantity, and I said in the previous class in the key points that displacement only depends on the initial and final positions. So the velocity also depends on the initial and final position, and it is the rate of change of position. So but in speed I mentioned the rate of distance covered. That is, it doesn't depend on the initial and final position. It depends on the path covered. So the formula of speed is distance by time. Distance by time, in which the formula of velocity is displacement per time. SI unit of both are same. That is, distance SI unit is meter, time SI unit is second. So the SI unit of speed is meter per second. Similarly, in this also, SI unit is meter per second. The dimensional formula of speed is m power 0, L power 1, T power minus 1, in which the dimensional formula of velocity is the same. That is m power 0, L power 1, T power minus 1. So we can denote speed by the small letter v and velocity as v bar. So we can denote velocity as v also, but while showing that velocity is a vector quantity, we have to write a bar above the letter. So speed, when for a moving body, speed cannot be 0 or negative. It must be always a positive number, in which velocity may be 0, negative or positive. So this is about speed and velocity. We will be studying the types of velocity further. So let us discuss the types of speed and velocity. So if you remember this thing, so whenever you are writing speed, you will write distance, and whenever you are writing velocity, you will write displacement. And speed doesn't have direction as distance doesn't have, and velocity have the direction as displacement have. So this is the key point. So let us discuss the types of speed and velocity. So the first type of speed is uniform speed. That is, when an object covers equal distances in equal intervals of time, we call it uniform speed. So I will show you this. So let us consider this part. An object has covered equal distances s in equal intervals of time t. So this is uniform speed. And uniform velocity, the type of velocity, the first one is uniform velocity. So the first type of velocity is uniform velocity. Uniform velocity is defined as equal displacement per equal intervals of time. So you consider this path itself. So here it has covered equal displacement s in equal intervals of time t. So this is uniform velocity. So now let us discuss the second type of speed, that is non-uniform speed. So non-uniform speed is defined as unequal distances covered per equal intervals of time. Sure. So I will show this. Consider this part. So an object has covered s1 distance in time t, s2 distance in time t as well. So now an object has covered s1 distance in time t and s2 distance in time t as well, but it has covered unequal distances in equal intervals of time. So this is non-uniform speed. So the second type of velocity is non-uniform velocity. So non-uniform velocity is defined as unequal displacement covered per equal intervals of time. So I can show you in this diagram. So an object has covered s1 displacement in time t and s2 displacement in time t. So here an object has covered unequal displacement in equal intervals of time. So it is non-uniform velocity. So let us look at average speed. So this is very important in the point of view of examinations. So average speed is defined as the total distance covered per total time. So let us discuss an example here. Consider an object has covered 20 meters in 5 seconds. So now they will ask calculate average speed. So you will calculate average speed as average speed is equal to distance is 20 meters. 20 by 5 is 4. So 4 meters per second. This is average speed. So when they have given the positions like they will say that at time t is equal to 4 seconds, the object is at 20 meters, and at time t is equal to 8 seconds, the object is at 32 meters. So they will ask you to find average speed. How will you calculate the average speed? By using this formula, s2 minus s1 by t2 minus t1, that is delta s by delta t. So you have to simply write as average speed is equal to s2 minus s1, that is 12 by t2 minus t1, that is 8 minus 4, that is 4. So 3 meter per second. Okay, is it clear to you? Let us see the third type of velocity now. So the third type of velocity is average velocity, as same as speed, average speed. So average velocity is defined as total displacement covered in total time, that is delta s by delta t. So this formula holds good for that also. So there is a fourth type of speed and velocity, that is instantaneous speed and instantaneous velocity. I will discuss that instantaneous speed and instantaneous velocity in the next class. So we will continue with the problems related to average speed and average velocity further. Let us discuss some problems related to average speed. So the problem 1. If a particle covers the first half distance with velocity v1 and second half distance with speed v2, find its average speed. So as I said you in the previous class, whenever there is a question in this chapter, you have to write the figure. So I am writing the figure now. So that they have given if a particle covers the first half distance This is the path which an object has traversed. The first half distance S is the first half of the distance. This is the second half of the distance. Okay. And thus said, it has covered first half distance with speed v1 and second half of the distance with speed v2. You remember this thing. Whenever they have asked you the question related to average speed, you have to substitute the given values in the unknown values. That is, for calculating average speed, you will write the distance per time, right? So here they have given velocity and distance, but they are not given you the time. So in place of time, you have to substitute the given values, that is v1 and s. How I will show you now. So solution. So average speed is equal to total distance per total time. What is the total distance? That is 2s. S plus s, that is 2s. And time. So you classify t1 time at velocity v1 and t2 time at velocity v2. So what is t1? So you have this formula, right? V is equal to s by t. So what is t? T is equal to s by v. T is equal to s by v. So in place of t1, you substitute s by v1, and in place of t2, you substitute s by v2. So 2s by t1 plus t2, that is s by v1 plus s by v2. So you take out s common, 2s by s into 1 by v1 plus 1 by v2. So s and s will be cancelled. So I will grab this. Now 2 by, we take LCM as v1 v2, that is v1 plus v2 by v1 v2. So the average speed will be 2 v1 v2 by v1 plus v2. I hope you are clear with this. When they are asking you the problems, they will give you the values. They will say that the velocity the velocity 1 will be 5 meter per second, the velocity 2 will be 10 meter per second. Find out the average speed. What will you do? It is 2 v1 v2 by v1 plus v2. We will substitute. So before I suggest you that you solve the given situation like this: v1 v2 ss. That is, you solve by keeping variables and then you substitute values. So it will be easier for you. So this is the average speed when time is not given. In your books they will give arithmetic mean, harmonic mean. So you don't bother about that, because if you are good at maths you can remember like this. But if you are not so good in maths, you have to go by the conceptual method and you have to solve each and every step, and you have to know which step is correct in which time, and you have to solve and you will get the velocity, so the average speed, and you will substitute the values. So this is about the problem 1. So next we will see the problem 2. So here the given, if a particle travels with speed v1 during first half time interval. I will write the figure. So they are given if a particle travels with speed v1 during first half time interval. Half time interval, not distance. This time interval. So you consider t and t as the time. So in first half time interval, it has covered with speed v1. So v1 in first half time interval, and with speed v2 with the second half time interval. Okay, this is the diagram. They have asked you to find average speed. Average speed is equal to S1 plus S2 by T1 plus T2. So now they have given velocity and time. They have not given distance. So you have to replace the unknown values with the known values. So how will you replace? So S is not given to you. So you know S is equal to Vt. Okay. So now S1 is equal to V1t and S2 is equal to V2t. So you will substitute that values here. So S1 is equal to V1t plus S2 is equal to V2t by T1 plus T2, that is T plus T. Okay, so now we can take out T common. T of V1 plus V2 by 2T. T cancel, that is V1 plus V2 by 2 is the average speed. This is the arithmetic mean. Okay, whereas this is the harmonic mean. So if you are good at mathematics, if they have not given you distance, it is arithmetic mean. If they have not given you time, then it is a harmonic mean. You can remember like that, or else you have to go step by step, and you will simplify the given problem into compressed form. So this is the problems. I will discuss with you some more problems in the meantime. Let us look at the third problem. A man travelled half of the distance with a velocity v0. The remaining part of the distance was covered with velocity v1. So I will write figure. So half of the distance s with a velocity v0, and remaining half of the distance was again covered with two intervals of time. Remaining part of the distance was covered with velocity v1 for half of the time, and with velocity v2 for the other half of the time. So find its average speed or velocity. So they are given half of the time with velocity v1 and remaining half of the time with velocity v2. So consider this to be t by 2 and t by 2, and this has S1 and S2. Okay. So solution. So average speed is equal to S1 plus S2 by T1 plus T2. So here S1 and S2 are same, that is S. So that is S plus S, that is 2S by T1 plus T2. So
write down this figure. So T1 is equal to S by V0. Why? Because V0 is equal to S by T1. So S by V0 plus T2 we have to find. So for that we consider this as A, B, C, D. For the interval BC, V1 is equal to S1 by T by 2. That is S1 is equal to V1 into T by 2. Okay? And for the interval CD, V2 is equal to S2 by T by 2. That is S2 is equal to V2 into T by 2. Okay? So what will it give while adding S1 and S2? It will give you S, right? So S1 plus S2 is equal to S is equal to, you have to add these two. So V1 into T by 2 plus V2 into T by 2. So you take out T by 2 common. So S1 plus S2. So from this you find out T, because we need T here. So you have to find T there. So T is equal to 2S by, this is not S1 plus S2, this is V1 plus V2. So 2S by V1 plus V2. I think you are comfortable with that one. So you have to substitute here in the place of T2. So T2 is 2S by V1 plus V2. 2S by V1 plus V2. Now we take out S common and cancel. So 2S by S into 1 by V1, sorry, 1 by V0 plus 2 by V1 plus V2. So S and S get cancelled. So I will rub this one. So now we take out LCM from this denominator, that is V1 plus V2 plus 2V0 by V0 into V1 plus V2. So 2 by V1 plus V2 plus 2V0 by V0 into V1 plus V2. That is equal to 2 into V0 into V1 plus V2 by V1 plus V2 plus 2V1. So this is the average speed. So this is the required thing. So I hope you are clear with this problem, and we will discuss one more problem further.
Let us discuss the fourth problem. A particle of mass 2 kg moves on a circular path. So the given mass, we call it out because while calculating the change in velocity or related to that, mass doesn't play any role. I have said in dimensional formula n power 0, that is mass doesn't have any impact on solving problems as like this. Okay, so particle of mass 2 kg moves on a circular path with constant speed 10 meter per second, and given speed not velocity. They have not mentioned direction. It is magnitude, 10 meter per second. Find the change in speed and magnitude of change in velocity when the particle completes of a revolution. Magnitude of change in velocity and change in speed. Okay. For that, first you have to write diagram. Okay. You consider initially a particle to be there, moving in clockwise direction. V is equal to 10 meter per second. So after half of a revolution, the particle comes above this point. So now the velocity will be in this direction. So V is equal to 10 meter per second. So there as change in speed. So change in speed is equal to V2 minus V1. So just subtract magnitude. So 10 minus 10, that is 0. 0 meter per second. So they were asked magnitude of change in velocity as well. So you consider this in vector form. So V is equal to minus 10 I cap, because it is in left direction, and for velocity you have to mention the direction in vectorial form or any form which you want. So the best way to represent velocity is in the vector form. So I mentioned V to be minus 10 I cap V1. So V2 is plus 10 I cap meter per second. Okay. So the change in velocity is V2 minus V1 is equal to, what is V2? That is 10 I cap. What is V1? Minus 10 I cap. That is minus of minus 10 I cap. So it will be 20 I cap. So they have asked you the magnitude of change in velocity. So the change in velocity is 20 meter per second. So this is about this problem. I hope you are clear with this problem, and we have discussed speed and velocity and types of speed and velocity in this class. So I have concluded this here, and we will be discussing instantaneous speed and instantaneous velocity along with differentiation and integration in the next class. Thank you so much. Don't forget to subscribe, and if you have liked this video, please press on to the like button and keep watching, keep tuned to this channel. Don't forget the name Tenacity. Thank you so much.